Hi, now we will understand how exactly the join happens internally within PySpark or Spark. We will understand what are the two main join strategies which are used by Spark. One of them it is broadcast join and second one it is shuffle hash join. So we will understand these in detail and then we will see practically also how it is decided which type of join to be used and how we can control like which type of join shall be used. So let's get started. We will start by understanding first what exactly is broadcast join. So let's say we are trying to join two tables or two data frames. One of them it is very big and one of them it is small. And when we say small, so by default let's say it is up to 10 MB of size. So what will happen is the large data frame or the table, it will be divided into partitions. So this is our driver and these are for our four worker nodes. So this larger data set, it will be divided among various partitions, let's say four partitions across these worker nodes. And what will happen to the smaller data frame, because it is very small, so there is no need to partition it across multiple nodes. What will happen is a copy of this small data frame, it will be broadcasted or it will be saved in memory of each of the worker nodes. So if we look at a particular worker node, the larger data frame, it is a portion of it is available, and for smaller data frame, it is completely a copy available in all the worker nodes. So when it will join these two, so what will happen is whatever rows are available for this larger data frame in this worker, those rows will be joined with this entire data frame and the result will be sent back. Similarly, whatever rows are available here, those will be joined with this entire data frame here. So that's how the joins will happen within each and every worker, and there is no need to send data across worker. Like it doesn't need to get any data from this data frame or from this small data frame because it has its own copy. So because there is no data movement across workers, so there will be no shuffling of data, and that is why it is very fast. So there is no shuffling and still it is doing it in a parallel way, because the large data frame or large table, it will still divide into partitions. But there is a limit how much we can use for broadcasting. By default it is 10 MB. We can increase it and we will see all those coding options in more detail. But first let's understand what happens if we have both the data sets are large and they cannot fit into memory. In that case, what happens is, let's say these are our four workers, and because both the data sets are large, so both will be divided into partitions. So here, let's say these yellow ones are our four workers, and these green ones, this is one table, one data frame, or one relation, whatever we call it. So it is divided into these four partitions. Similarly, relation 2, this is our second table or data frame, which is again divided into four sections. So now let's say if it has to join this relation 1 with the second table. So now because second table, it is also divided into partition across multiple workers. So there is no guarantee that all the corresponding IDs that we need to join, those from relation 1 are in the same worker for relation 2 also. And because those can be available in a different worker, that's where shuffling will happen. So what will happen is it will take one relation and then for the relation wise it will try to gather all the corresponding keys into a single worker. So for example, in our worker 1, let's say the wherever it is join key equal to 1 from green and red, those the data will be traveling to this worker. Similarly, wherever the joining key is 2, that data will be traveling to this worker. Similarly, the corresponding rows where the values are same in both the tables, those will travel to a single worker so that it can join them in that worker. And because the data is traveling a lot across workers, that is called as shuffling, and in this shuffle hash join, shuffling will happen for sure, and that is why it will be slow as compared to broadcast join. But if our table size are bigger, which cannot be within the broadcast limit, or we can, after increasing the limit also, if cannot fit into memory, like into a single worker memory, then this type of join will be used and there is no other alternate to that. So it will be slower, but because both of the data sets are large, so we can't do anything. Still it will do shuffle hash join only. So this is how like shuffle hash join works, and these are the mainly these two strategies are used. So if one of the data frame or table is small enough, it will do broadcast join. If both are big, it will do shuffle hash join. So now let's understand in terms of coding how exactly we can know which type of join is being used and how we can control it. So this is my Databricks workspace, and here I have created two sample data frames. One is employee, another one is salary. These two we are going to join together. So in employee we have columns like employee ID, name and city, and in salary it is employee ID, salary and department, and these two can be joined using this employee ID column. So first let's understand how we can control like how much data will be broadcasted. So as I was telling, the default limit it is 10 MB. So if it is up to 10 MB, then Spark automatically it will use broadcast join only, and we can get this value using this command line like spark.conf, which is configuration .get, like we can get the configuration, and this is the configuration which controls it, like spark.sql.autoBroadcastJoinThreshold. So what it means is if we increase it, then even if we have bigger data set, those also it will use broadcast joining. So by default, if we try to get it, it will be 10 MB, but it depends on compute also. Currently, I'm using this free edition, and here it is serverless compute. So for serverless compute, setting the Spark configurations are currently not supported. So if we are using all-purpose kind of compute, then we will be getting the value as 10 MB, and we can set this value also like this. So using spark.conf.set, and then we can set this value, for example, to 1 GB or even further if we want to. After setting, we can again check whether it is increased or not. So after we set it, then what will happen is if one of the dataset, even if it is greater than 10 MB and up to 1 GB, then it will still do broadcasting, and that way the joining will be faster. But we need to be careful how much we want to increase this limit, because if we increase it, again we are sending a copy of the smaller dataset to all the executors. The data is being replicated, and if the dataset is bigger, it is taking more memory of the worker also. So we cannot keep increasing it because it cannot be more than the worker memory, and within worker there are some other operations also to it, so it has to be like less than the worker memory, some very less value. But again, depending on our scenario, we can try increasing it and then see the impact and then decide what shall be the optimal value. But practically I have seen that increasing this from 10 MB to 500 MB or 1 GB, it increases the performance a lot. So we can try out and then decide what shall be the best value. And next, let's understand how exactly we can know whether it is using broadcast join or the shuffle hash join. So that is where whatever data frame we are doing, after that we have this command explain. What it will do is it will find the physical plan of this data frame operation that we have specified, and that plan it will explain us. So here what it is doing is we can see that first it is scanning two data frames. and after scanning, like it is doing some other operation, and then we can see the join mentioned here. It is saying it is photon broadcast hash join. So basically it is saying that it will use broadcast hash join. Photon, it is an accelerator within Databricks, which they have mentioned. It may or may not be there depending on your cluster. But from here we can understand that it is using broadcast hash join or hash shuffle join. And this same thing we can understand in SQL as well. So in SQL also we have this explain command. So if we put this command before any query, it will explain the command and we can see the type of join. And this explain command, it is very powerful. It is not only to find out the type of join, but if we have a very complex operation, we can first run explain and then understand how it is doing that operation step by step, so that like we can analyze if it is pushing down our filters or not, or whether it is picking the required columns at the required stage and all. So sometimes it may help us to understand internally how Spark is planning to execute our code. So that's where it may be helpful. And next, we have another command in Spark where we can provide a hint to Spark that this data frame shall be used for broadcasting. And how that works is, like if in our join query, in the inner data frame, if we mention dot hint broadcast, then also it will try to broadcast it. So again, it is not guaranteed that it will use broadcasting for sure. It can still check based on the limit and other parameters, but it is a hint we are giving to Spark, you shall use broadcasting for this data frame. So it is not that much useful, but sometimes depending on the scenario, we may try it out and then see if based on our hint, Spark is doing the broadcasting or not. And this hint, it is available in terms of SQL also. So here it is provided like this, even though this is read as a comment, but this is a standard comment available in Spark SQL. So if we mention the comment this way, then it will try to broadcast the view or table mentioned in that SQL query. So this is how overall we can control the flow. So in general, by default, if our data set is within the broadcast join threshold limit, it will try to do broadcasting automatically. If we want to increase the limit, we can increase using that property that we saw, and we can additionally provide the hint also in our data frame or SQL operation, so that Spark understand that this is the table or data frame we want to broadcast. And if it is not able to broadcast that smaller data set to the worker due to the size and other limitation, then it will go for the shuffle hash join. And shuffle hash join also, so that is the only option for bigger data sets, and that's how Spark works. So this is all about the joining strategies, and I hope you got good understanding now how Spark internally joins the table. So if you still have any doubts, then let me know. For now, that's all I wanted to explain. Thank you. Bye bye.